welcome back. We will see the object-oriented programming using Python in this session and some forthcoming sessions. So far we have discussed or we have written programs in a procedural-oriented way, right? Yeah, whatever we have to solve, we are writing it as a function, okay? Either as a single function or a set of functions, depending on the complexity of our problem in hand, right? Yeah. So in general, we can classify the programming paradigms or the way in which programs can be written into two different categories. The first one is actually procedure oriented programming. In the case of procedure oriented programming, we will write the entire program or entire task as a set of functions depending on the complexity. The entire task will be divided into a set of subtasks or as a single task we can solve it. So for every task we will write a function or procedure, right? And that is called actually procedure oriented programming. So C programming language is an example for this procedure oriented programming. And in so far we have written the Python programs also in that way, right? Yeah, a set of functions or a single function. But Python is actually a second category of programming language, that is object oriented programming. So if you want to model the real world problem as such, that is real world, there is no direct task, right? We are everything is based on a object, a set of objects, right? So if you take a real world object, it will have a set of attributes, we can say properties. Just for example, if you are thinking of a person will have a name or address, like that. A set of properties will be there for every person, right? And a set of operations on a person is also there, like if you want to calculate the age based on the date of birth. So date of birth is a property or attribute of a person, and we can calculate the age using the current date, like that. So a set of operations also will be there with a person. Or if you are taking another example, a bank account. In that case, bank account can be treated as an object, right? It is having some properties like account number, account holder name, branch, like that. A set of properties are there. A set of operations on that account also there, right? Yeah, checking the balance, depositing money, withdrawing money, like that. A set of operations also there. So if you want to model a real world problem as such using a program, we can use this object oriented programming language. And that is the motivation behind this object oriented programming language. And in Python is also designed as a object oriented programming language. So we will see how the programs can be written in that way in Python. So we can say that object is a collection of data, that is variables and methods or functions. And another term, class. Class is a blueprint for the object. So if we are grouping all the objects of similar kind, we can call it as a class. Just for example, person is a class in which all of us are members. Area is a object, right? Or another person, Asha is another object. Okay, so all these are objects, and if we group all these persons together, the common attributes, we can call it as an envelope for all these objects. So that we can call it as the class. Okay, so class is a blueprint for the object. So person is a class in which every particular persons are objects. So object, we can call it as an instance of a class. And the process of creating this object from a class, that is called instantiation. So we'll see how we can define a new class in Python program. This is the syntax. We have to use this keyword class. Then we can give a class name here using the same conventions for giving name for identifiers and all. And inside the bracket, either we can specify the parent class. We will see what is parent class and all. That is not a mandatory field. If we are using or inheriting some properties from the parent class, we can specify who is the parent for this class. And after the closing brace, we can put a colon. So this is the header for the class definition. Then inside that, we can define different methods belong to this class. So these are the syntax for class definition. Now we'll see an example for how to define a class. So here we are taking the example, an employee class. So employee is a class. So every person who are employees are objects of this class. Okay. So let us define this class first. Then we can create or instantiate this class to create specific employees. So this is the syntax for that. Class, we are giving the keyword class. Then name for that class, we are omitting that part, parent class part here. Then inside that we can have an optional doc string. Okay, option, just like in functions and all, we can describe a particular function, what the function do. Like that class also we can describe the class using a doc string here. So that is the first part, that is also optional. Then if we have some variables, that is called class variables, that is common for all the objects of this class. Such variables we can specify here. You can see here the employee count. From the name itself, you can guess that employee count is the total number of employees belonging to this class. Okay, so that's a common variable that can be specified or defined within the class itself, and all the methods in the class also we can define. So just like any other function, class methods also can be defined using this def keyword. And there is a special method in every class, that is actually init. Actually that should be written like this: double underscore, then init, again double underscore. Then any class, the first argument for the method should be self. Self in the sense, actually we are referring to the current object. That's the meaning of self. So if we are taking a variable for a particular object, self dot that variable name means we are referring the current object. So every method definition, the first argument should be self. Then the next arguments we need, actually that name and salary are the arguments here. And function or the operation within this method is actually self dot name is equal to name. So in the method also we are using the same variable name, and the meaning is that, so when we call this init function, we will see how it can be invoked. Okay, and we are giving two arguments here, name and salary. The first value, that is name, value of the name will be assigned to the attribute name in this object, and the second attribute value, that is salary value, whatever we are passing here, that will be assigned to the second attribute, salary attribute of this object. And this employee.emp count, usually the variables which belong to a particular class we will refer is using self dot. Okay, whatever this common variable, this is a class variable, emp count, we define inside the class, right, not within an object. That is why we are referring it using the class name itself. Employee is the class name, dot emp count means class, we are updating the class variable emp count by 1. And the next function just display self. So even if we are not passing any argument, one argument should be there in the method definition, that is self. So here we are simply displaying the count of employees. The total employees count as employee.emp count. And the next function is display employee. So there we will display the details of the current employee by printing like this: name, that self dot name, the current object's name, current object salary. So these are the different method definition. Then we will see how to instantiate this class to create different objects, and how to use the corresponding methods and all. So in case of function definition also, first we will define the functions, right? Then how to use that function only by calling those functions. At the time of calling only, this function is actually getting executed and passing the values to these parameters and all, right? Yeah, the same thing happens in the case of class also. First we will define the class and the methods for that class. Then we will create objects, and only we are giving life to this class objects. Okay, how we can create objects? Yeah, we are giving a variable name to one object, emp1. And how it can be created, the class name. Then inside that, either we can simply put brackets, just like a function call, simply put brackets, or we can put some values here. You can see the first method, init. This is actually a special method, that is why we are giving some underscores in both sides of this init. And the function of this init method is that it is acting as a constructor. In Java also, Java is a object-oriented programming language. Java also we have constructor. Constructor in the sense, when we create a new object, the initialization, the initial value for the different instance variables and the methods also, we can execute using this init. We need not call the init method separately, but at the time of creating the object itself, that init method will be invoked automatically. So that is why we are passing parameters here, Sarah and 2000. So what will happen here is, when we call this, we are creating a new object that is called instantiation, and emp1 we are referring the new object. Okay, that is actually an object belong to this employee class, and we are passing two values. So this will be assigned to the init. Okay, so first argument always should be self, that referring to the current object, and the second and third are the actual parameters, right? Yeah, this is name and the second one is salary. So the first argument from the call, the constructor or the init method, or the at the time of object invocation, that will be assigned to the first variable here, that is name, and the second will be, this 2000 will be assigned to the salary, and this init method will be invoked automatically. So what will happen when we create an object by executing this statement? Yeah, the self dot name is equal to name. So for the current object, that is emp1, the name for emp1 will be the name passed here. What is the name passed here? That is Sarah. And the second statement is that self dot salary. For emp1, the salary for emp1 will be the salary assigned as argument here, that is 2000. So these two statements will be executed, then the employee count will be updated. This is a class variable. Now its value will be 1 after creating the first object. So this is the invocation or instantiation. Now we are going to create another object, emp2, employee 2. Again we are invoking this constructor. Employee is the class name. This is syntax for invoking or instantiate a class. Okay, and the name is money, and 5000 is the salary. Again this init method will be invoked. For emp2, the name will be what, money, and the corresponding salary will be 5000. Employee count is also updated here. Now it will be 2. And we are invoking the corresponding methods. So all the class methods we can use or invoke in the corresponding employee objects. So emp1.display employee, what will happen? The corresponding function will work, and name will be displayed and salary will be displayed. We will see the output for this function. So output will be name, then Zara, salary, then 2000. That will be the output for this emp1 display employee. Then we are calling this emp2 display employee. Again the name will be name, money, and salary 5000. That will be displayed, and printing the total employee count 2 will be displayed in the statement. So this is about the class and corresponding object instantiation. So the variable emp count is a class variable whose value is shared among all the instances of this class. That is why it's a common, just like a global variable and all. It's common to all the employees or the objects belonging to this class. That is why we are referring it to as class name dot the corresponding variable name. For all other variables which are referring to a particular object, we will call the corresponding object name. Just for example, emp1 dot name, emp2 dot name. That is specific to that corresponding object only. But here that is specific to the entire class. The first method in it is a special method which is called constructor, class constructor, or initialization method that Python calls when you create a new instance of this class. You declare other class methods like normal function, with the exception that the first argument to each method is self. Python adds a self argument to the list for you. You do not need to include it when you call the method. At the time of calling, we will specify the other arguments only. You remember here that when we call the function, there is no self, right? Only this second and third argument value will be passed. Self is actually referring the current object. So in this case, it referred to MP1, and in this case, it will refer to MP2. Okay. And employee class, creating an instance object. To create an instance of a class, you call the class using the class name and pass in whatever arguments. It's init method accept that arguments. Accessing attributes, you can access the object's attribute using dot operator, emp1.name, emp1.salary. So object name dot attribute name, that is accessing attributes. And the initialization method is a special method that is invoked when an object is created. So should be specified like this: 2 underscore characters followed by init and again 2 more underscores. Now you will see how this class is actually organized in any programming language, object-oriented programming language. That is actually defined as a hierarchy. Hierarchy in the sense, programming language, it's organized as a tree-like structure. You can see here there is a root. For that there is a 3 different child classes. Then again for B we have 2 different child classes, like that. So in case of Python, the root for the entire class definition is object, a particular class, built-in class, that is called object. So all the abstract properties, that is all the properties which are common for all the objects belonging to any objects we are going to create, that properties will be defined in this abstract class. So this property is defined in this abstract class, or the object class in our case. It inherited by all the objects we are going to create. Okay, implicitly those properties will be there in every object. So we can say that B, if we are taking the case of B inherits the properties of A, and E and F are actually subclasses of B, right? So E inherits all the properties acquired by B inherits the properties of A, like that. That is a hierarchical order in which different classes are arranged. So we can say that B is the parent class for E, and E is a subclass of B, like that. So at the top of the root of this tree is the most abstract class named object, which is built in. Each class immediately below another class in this hierarchy is referred to as the subclass. Class immediately above it, therefore, is the parent class. We will see an example which is given in your textbook, that is a class student. Okay. So in the earlier definition of employee class, we have omitted this part, right? Yeah, parent class was not there, but here we are specifying it as object. Actually, object is implicitly there for every class definition. So this is actually optional. Even if we are not referring it or defining it as like this, the properties object can be acquired by student. So here explicitly we are saying that object is a parent class for student. And docstring is there to represent or to define or describe the corresponding class. We have a docstring. And we are defining different functions or methods in this class. First is the constructor method, that is init. We have 2 different arguments for that, name and number. So when we create a new student object, the name and number of that student can be automatically initialized. So this is the self.name is equal to name. So here this name actually instance variable for the current object. Whatever new object we are creating, for that the first attribute is actually underscore name, and whatever we are passing at the time of creating the object, that value will be assigned here. Okay, so we can simply use the same variable name here and here. Self.name is equal to name means we are referring the corresponding instance variable as name, and the variable or the argument here also the same name. Okay, just to differentiate those two, we are using the underscore here. Okay, and the second thing is self.scores is equal to some initially empty list. We will add later using the number. You can see here that for counted range number, self.scores.append 0. So we are initializing the score matrix. It's actually a list here, initializing it with the empty list first, and whatever we are passing as number here, okay, that much entry should be there in the list. That is the meaning of that. That is why for count in range number. So if we are passing 10 as the number here, so 0 to 9 will be there in the for loop, right? Yeah, self.scores should append 0. That much zeros will be appended to the scores matrix or scores list. Okay, so initialization will be over by carrying this init function. Then another function get name to display the name of the current student object. Then score of the student also can be displayed using this set score. You can set a new score for a student particular position, the first score or second score. If you're getting the marks of first subject, you can set specifically that. Okay, so we are passing, if we are passing 1 as the value here, that means 0th or the first entry in the corresponding score list will be updated. So get score, we can retrieve the current score of a particular position or particular subject using this get score function. Like that average, high score, like that a set of functions are there. And also we have another optional function string, that's actually to return the a string description of the corresponding object. That's also not mandatory, either we can use it or not. So this the different interfaces, so the different methods provided by the class. First one is student, actually that initialization returns student object with the given name and number of scores. Each score is initialized to 0. And get name, get score, get name returns the student's name, return get score returns the student's ith score. I must be in a range 1 through the number of scores. And set score, we can specify a particular, we can set a particular score. Position we have to specify first, then we have to set the value, specify the value to be set. Then get average, get a score, like that. You can see an example for this. See here we are calling that current constructor method. So we are creating a new object student, S, small s, that is the object name. Type is student, that's the class name. Then inside the bracket, the arguments for initialization. Name and score number. Number are the arguments, right? Name is Atul here and the number of scores is 5. So what's the meaning of this statement? Actually, we are creating a new object, small s, that is student type. Okay, so we are instantiating the class students. Class student we are already defined. From that we are creating a new object whose name is s. Okay, and we are passing two values to at the init method. What are the different arguments? Those we can assign here. So Atul and 5 are the argument we are passing. That means this first argument will be assigned to the first argument inside the init. That was name. So name for this s will be now Atul. And the second argument in the init method was number, right? The number of scores, that is 5. So we have to store this scores for 5 different subjects. You can guess like that. So 5 is the score. So what will happen? 5 different values in the score list for this student S will be initialized. Okay, all will be initialized to 0, right? Because we are appending 0 to this much number of times. So if we try to print this, we will get the name of the corresponding object as Atul and the scores will be 5 different zeros. Now we can call any methods defined in the class for this particular object. So for this student object we are setting score using the set score method. S dot set score 1, 25. Inside the set score our arguments were, you can see here, I and score. I is the which position we have to set the score and what value should be set. That is why we are passing two arguments 1 and 25. The position 1 we have to set the values 25. Now if we check the corresponding values, again printing, the name is Atul and the corresponding value, the first value we are setting it as 25 instead of 0. Okay, like that we can change the or set the second value. 2, 45. Then if we try to print it, this will be the result 25, 45, 00. Like that, all the methods defined in the class can be invoked for this particular object. Coming to instance variable. Instance variable means actually the variables belonging to each particular object. Attributes an object, that is called instance variable. Just for example, in our earlier case, s dot name. So name is actually an instance variable, or s dot scores, another instant variable. Each individual object has its own set of instance variable. Okay, and these variables serve as storage for a state. State of an object means the current value for that object. Okay, for a particular object. Just for example, state of Abin is a name. Roll number may be there. So Abin 35. Address may be there. That current value of the address, that also will be there. So current value of an object is called actually state of an object. So this instance variable as memory spaces for storing the state of an object. Scope of an instance variable including self is the entire class definition. So where we can refer these instance variable, definitely within the class definition. Whenever the class definition ends, we cannot access those instance variable. And all the class method can refer instance variable. So we will define different class methods, right? Inside any of these class methods, we can refer these instance variables. And lifetime of an instance variable. So instance variable is actually part of an object, right? So whenever this object is there, this instance variable is also there. Whenever the object is removed, it is deleted from our program, the corresponding object variable also will be removed. That is why a lifetime of an instant variable is the lifetime of the enclosing object. And names of instant variable must begin with self. So if you refer a particular instance variable belonging to a particular object, we should refer it as self.name, self.salary, like that. And let us see two more new terms, accessors and mutators. So methods that allow a user to observe but not change the state of an object are called accessors. So we can see the current state of an object using this accessor, but we cannot modify it. Just for example, in our case, display the name of an object. Such a method can be there in a class, right? Just to display, we can see the name of a particular object using that function, but never we can modify, we can assign new value or a new name for that object. Such methods are called accessors. And the second one is mutators, method that allow a user to modify an object state. We can modify also, we can see the current value or we can modify it also. Such methods are called mutators. Just for example, in our case, set score, we are setting or we are changing the current score of that student, right? Yeah, that is actually mutator. But get score, whatever get score means we are getting or we are accessing the score, we are seeing the score of a particular student. That is actually an example for accessor method. Now some rules of thumb for defining a simple class. First one, think about the behavior and attributes of the objects of the new class. First we have to think what are the different attributes that may be there in a particular class. That we have to think of first. Then choose an appropriate class name based on the nature of the class. We have to specify like student or employee, like that. We can specify based on the nature and develop a short list of the methods available to users. So what are the different operations possible? What are the required operations? That also should be enlisted. Then write a short script that appears to use a new class in an appropriate way. Choose the appropriate data structure to represent the attributes. So what are the different attributes? What type of data type should be, what data structure should be used. Just for example, in case of a person, if you are taking the case of person class, you can have a set of attributes like name of the person, address of the person, like that, right? Yeah, name we can use as a string, or address we can use it as a list, or depending on the type of attribute, we have to choose appropriate data structure. Then fill in the remaining class template with a constructor init method or optional string method to return the entire object state using this str method, and complete and test the remaining methods incrementally. This is how a class can be defined. So these are all about the basics of a class definition. The remaining we can see later.